Go ahead and copy down your target for today. The next section we're going to be talking about is powers of 10 and scientific notation. For a lot of you, this will probably be a review, but please take your time, go through it, be careful on it, because it is good to review this before we get into evaluating other terms with exponents. So copy down your target, work on your warm-up, pause the video, come back to me when you're done. All right, so on the first one, we know that 4 cubed is 4 times 4 times 4, which is going to give me 64. On the second one, we know 9 squared. That means we have 9 times 9. The exponent tells you how many times you are multiplying it out. We get 81. On the next one, we have 10 times 10, which gives me 100. And on the last one, this one's a little tricky, but if you remember from your warm-up notes, from your introduction, we know that that negative exponent actually means 1 over 10 cubed. Now you can do that. We know it's 1 over 10 times 10 times 10, which gives me 1 over 1,000. So if you have that, that's great. I'm going to be picky here. I want that comma in there, okay? Let's keep our correct numerical form. So scientific notation, what is it used for? What's the point of it? I'm sure you guys can tell me science. You're going to tell me you use it in science class. And you're right, you do. You use it to represent really big things or also really small things. And it's just kind of like a nice shortcut to write things in a more concise way. Makes it look neater. Could you imagine how much bigger your science textbook would be if every number in there was written out in standard form? You'd probably be adding multiple pages to your book. It'd be a good experiment to try. So this table here, you saw it already in your introduction, but just to remind you. So we know that if we're dividing by powers of 10, that exponent is decreasing by 1. When we divide by a power of 10 again, we end up having a negative exponent, and that's a fraction. It's 1 over 10. So those are the rules that I want you to know from 7-1. So when we think about it, a positive integer exponent, if we want to find 10 to the nth power, we always start with 1, and then we move the decimal point n places to the right. Make yourself an example here. I'm going to use 10 to the 5th. If I want to find 10 to the 5th power, I start with 1, and then I know that I'm moving the decimal, since it's to a positive exponent, over to the right to make it a larger number. So I'm going to have 1 and then 5 zeros. Put your commas in. Whereas if you have a negative exponent, it's the same as starting with 10 to the nth, but if n is negative, you start with 1, and you're going to move your decimal place this time n places to the left. So make yourself an example here. Maybe I have 10 to the negative 3rd. We could write that out as the fraction, and then we could simplify it down to the decimal. But if I just want the decimal right away, this is going to start with a 1. Now I need to make this number smaller because it's a negative exponent. So I wouldn't go to the right. If I add zeros behind it, that would make it larger. Instead, I go to the left. So by going to the left, I would then have 2 zeros in front of that 1. Don't forget to put your decimal place, and then you really should, guys, put a 0 in front of that to hold the decimal up. That's the correct way to write those numbers. So negative exponent, think it's a small number. It's got to be moving, the decimal's moving to the left. Positive exponent, it's got to be a large number. Means the decimal's moving to the right. So for example 1, copy down your A, B, and C. We're going to do A and B. You're going to do C. You will then enter this answer on the quick check after the video. There'll be some other questions like this as well. So copy down the original problem. Make sure you have that first, and then show me your work. So if you think about this, we see a negative exponent. I'd be starting with 1. It's going to be a really big or really small number. Really small. So take that decimal place. Right now, the 1 would have a decimal right here. You're going to move it 6 places to the left. Don't circle your answer with these loops under it, okay? So now show me what your answer would be. There's my decimal place, and I'm going to move my equal sign over a little bit so that I can add in that 0 to hold that decimal up. The next one, 10 to the 4th. So positive exponent, I'm going to start with the 1. My decimal is always after the number if you don't see it. Moving it 4 places to the right now. It's a really large number. Then your answer would have 1, 2, 3, 4 numbers, 4 zeros after it. Then put in your commas for me. Please make sure you put your commas in. It's going to help me to look at your work. It's also the right way to do it. So I want you to try C. You can pause the video if you need to, and then you'll be putting that answer in afterwards. So always remember, where is the decimal point if you can't see it in a number? If I had the number 21, where would my decimal point be? Is it before the 2? Is this the same thing as 21? No. Is it between the 2 and the 1? Is that the same thing as 21? No, definitely not. These are not equivalent. If you had $21 and I had 21 cents, I would not say we have the same amount of money. If you have $21 and I have $2.01 or 10 cents, I would not say you have the same amount of money, right? So the decimal place would have to be after the number. Always remember that. The decimal would always be, if you don't see it, on the right of the number. So then we can do the opposite. Instead of being given the power of 10, you could be given the number in standard form and you need to write it as a power of 10. Remember, you're starting with 1. So how many places would you be moving it to get to the 1? We would have 1, 2, 3, 4, 5, 6. And then remember that it's always a power of 10. We know it's a positive 6 because this is a really big number. Take a look at the next one. Okay, really small number. What kind of exponent are you going to have? You should know right away it's going to be a negative exponent. So put that down. You want to rewrite this as a power of 10. You just have to move that decimal, though, until you get a 1. That's the rule. So 1, 2, 3, 4. It'd be 10 to the negative 4th. Same thing here, guys. You're going to do C. You will enter this answer on your quick quiz after you do the notes. So pause the video if you need to. I'm moving on to example 3. For example 3, you're going to do B on your own. We're going to do A together. If I want to actually find the value of the expression, you're just going to multiply it out, okay? Think about what this 10 to the 8th means. 10 to the 8th means 1 with 8 zeros after it. So we would have 100,000. If I were to actually multiply 23.89 times 100,000, what is that really the same as, or what is that going to do? All it's going to do, guys, is move your decimal. Think about it. Is this decimal going to head towards the left and make the number smaller if I multiply it by 100,000? Or is this decimal going to move towards the right and make the number larger if I multiply it by 100,000? If you're multiplying by 100,000, your number should definitely get larger. So count it out. You need to move it 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. So you're going to have 2, 3, 8, 9, and then 1, 2, 3, 4, 5, 6 zeros. Put your commas in then. Yes, I want to see those. Okay? Again, you're going to do B, guys, so think about which way you would move the decimal to match this negative exponent. Is that a really small number or a really large number? When you're done with that one, guys, again, if you need to pause the video, you go ahead. Keep in mind there are 2 parts of scientific notation, and I want you to write this on your notes. So you have the first part is a number that is greater than or equal to 1, but it's also less than 10. It has to match that criteria, okay? And the second part is always a power of 10. So write that down on your notes. Again, pause the video if you need to. So we're going to convert back and forth between standard and scientific notation. Make sure you know which one's which. This number, guys, would be in scientific notation form. Okay, it's a number between 1 and 10 times a power of 10. Whereas this number over here is already starting in standard form. We're just going to convert them back to whichever one they're not in. For this first example, write Saturn's diameter in standard form. So Saturn's diameter is 1.2 times 10 to the 5th. Standard form would be multiplying that out. Really big or really small number? Really big. So move the decimal 5 places to the right. We are talking about something now. We're talking about Saturn's diameter, so put your units on there and circle your answer. If we want to write Saturn's distance from the Sun in scientific notation, this would be the one that's starting in standard form. Remember, to get it in scientific notation, you need a number between 1 and 10. Where's your decimal right now? Right here. How many places do you have to move it to get it to be a number between 1 and 10? 1, 2, 3, 4, 5, 6, 7, 8. Can I end right there? No, 9. So I moved it 9 places. That's going to help you with your exponent. You have to decide, is this going to be a positive or negative exponent? Is this a really big number or a really small number? It's really big, so your exponent will be positive. And now you're going to, if you put that decimal there, you would have 1.427 times 10 to the 9th. I want to ask you a question here. If I had written 14.27 times 10 to the 8th, two questions. Is this the same number as this? Second question, are they equivalent? Second question, are they both in scientific notation? So think about that. Are these two numbers equivalent? They are, because if you move this decimal over 9 places, and if you move this decimal over 8 places, they would both get you back to here. However, are they both in scientific notation? Hopefully, you're telling me no. Why not? This one is not a number greater than or equal to 1 and less than 10. It would be over 10. So this would not be in scientific notation. I would not be able to take that as an acceptable answer. So we don't want that one. This is your answer here. Okay? So for example 5 then, if we want to try ordering these numbers from least to greatest, start by looking at their exponents. Look at the exponents first, right? Okay, we have -3, 14, -3, -12, 30, and 14. Put it in from least to greatest. Which number is going to be the smallest number? Well, the one with the most negative exponent is going to be the smallest. Which one's more negative, guys? -3 or -12? On a number line, -12 is way over here, -3 is right here. So -12 is going to be the most negative. That's your smallest number first. Okay, we did that one. Now your next smallest exponent would be the -3's. You have 2 of them. Think about what these numbers are. This would be 0.052 with the decimal in front of that. This would be 0.004 with a decimal in front of that. Which one's smaller then, guys? The smaller one would be the 4, so we're going to have 4 times 10 to the -3rd, then the 5.2 times 10 to the -3rd. Those two are done. Look at the next exponents. Which ones? These two match as well. Which one's smaller? The 3. And the last one would be 4.5 times 10 to the 30th. Last example then, guys. I'm going to do A, you're going to do B. When you do the multiplication with scientific notation, you need to think about these two properties. The commutative property allows you to move terms around. When you're multiplying multiple things, you can move the terms in whatever order you want. The associative property allows you to regroup the terms then. You're allowed to regroup the numbers in any order with multiplication. So when you take a look at this first example, what does this mean? This is just multiplication. What's happening in there? Just multiplication. What's happening right there? Just multiplication. So you can rewrite this in any order that you want. It makes more sense to multiply these terms together. So put those, 3.6 times 3, and then regroup the 10s together. 10 squared times 10 to the 15th. You can do this, guys. 3.6 times 3. Take a second to do that. 10.8 times. Now, if you have 2 10s being multiplied here and 15 10s being multiplied here, how many 10s do you have being multiplied all together? 17. Last step then, guys, check your answer. Is it in scientific notation? Is it a number between 1 and 10? No, it is not. So you have one more step. We need to move this over. By moving that over, you're going to have 1.08 times 10 to the what now? If you made this one smaller, you need to make this exponent larger to counteract that, to keep it the same number. So you would have 10 to the 18th. You're trying B, guys. Copy it down. That's it. You'll go on to your quick check afterwards.